Alright, section 14.4, addition and subtraction with rational expressions, moving on from multiplication and division. Okay, the way you would think about these, if you notice from the example given below, we're going to add and subtract these the exact same way in which we would add and subtract regular fractions. Notice here when you have p over q plus r over q, you can add those together fine because you have the same denominator. That's exactly what we're going to be doing. We're going to be trying to create the same denominator amongst every single rational expression before we start to add them together. Okay, and this is going to be one of those chapters that just a lot of examples is going to help out a lot easier. Okay, so looking at this first little example here, I want you to see same denominator here, same denominator here. Whenever you have the same denominator, okay, let's put this under here, okay, same denominator, okay, erase that part there, you can combine it under, okay. So that is going to give you, whenever you combine these, you're literally just going to have it. Oops. Okay, you're going to have x plus 1 all over x squared minus 1. Now, when you look at this one right here, because here we have a difference of perfect squares. So if we keep on going with this, we're going to end up having x plus 1 all over, well, a difference of perfect squares is going to turn into x plus 1 and x plus 1, which in turn, these two are going to reduce out, leaving us 1 over x plus 1. Okay, so, and that right there is going to be the basis of this whole lesson. Yeah, they all going to be that simple? No, unfortunately not, but we're going to kind of work them out as best we can. Okay, adding rational expressions with different denominators, find the LCD or LCM, rewrite each fraction in equivalence form, add the numerators, reduce if possible. Like I said, let's just do an example so you can kind of see. Notice here on this one, we have that denominator there, and then we have this denominator there. They are not the same. But if I was to show you two different fractions, okay, and they both had different denominators, we would know that we would need to find a common multiple. Sometimes, you know, those common multiples we would multiply together. That's exactly what we're going to be doing right now. Our least common multiples, okay, are, not y, okay, and then here, after I get my least common multiples, I got y minus 3, y plus 4, and if you hear a little glitch in there, try to edit something out real fast. Let me come down here, and I'll show you exactly how this is going to work out now. Now that I have common multiples, this should be quite familiar if you remember this was fractions. Remember, try to always get this back to how it feels like with fractions. Okay, I'm going to have y, a little bit longer of the line, y minus 3. Well, I already got a y minus 3 here, so let's go and do a y plus 4. And then what I do to the bottom, I have to do to the top. Plus, well, we got a 6 here, and then I've got a y plus 4, but I'm lacking the y minus 3. What I do to the bottom, I also here have to do to the top. Okay, well, let's take this here, and let's distribute that out, and distribute that out right there. Okay, the bottom I don't have to do anything to. The bottom I'm perfectly happy with right now. Okay, so let's kind of continue on. Draw a little bit of a longer line here, and I'm going to have the y plus 4 and the y minus 3 on the bottom. Here I'm going to end up having y squared plus 4y. I've got a plus here, plus 6y minus 18. Well, we're going to continue. We don't have to continue simplifying it. I want to show you what you can do real quick here. Notice I've got 4 terms here. So why not come in here And let's go ahead and group these guys just like this. Okay, here I can factor out a y. Okay, here I can factor out a, looks like a 6. Okay, well when I factor all that out, let's kind of come down here at the bottom here. Well, this is going to end up being right here. I'm going to end up getting a y plus 6. Well, when I factor that y out of this one, I'm going to end up having a y plus 4. Well, when I factor a 6 out of this one, notice that 6 went over here. Okay, so that's going to leave me with a what? A y minus 3. And then notice here on the bottom, I have y plus 4. And then y minus 3. Well, we can just start factoring away, can't we? Look at that, those 4's cancel, the 3's cancels. And so our final answer for this one is going to be y plus 6. Okay. Some rationale. Let's put this up here, and I'll kind of just do this as like kind of a note. Okay, let me see here. Note. Why did I do it this way? Well, let's look at something like 1/2 plus 3 over 6. If I want these to have the same denominator, I'm going to come back over here on this one and multiply everything by 3. And then you're going to end up having, okay, 3 over 6 plus 3 over 6. Okay, and yes, this whole thing right here would equal out to 1. But you notice what I did here. That's the exact same thing I did here, 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 and here. I'm just creating the same denominator is all I'm doing. Okay, let's continue on. Same thing. Okay, you're going to do the same exact thing. We're trying to create the same denominator. Okay, except now we're just subtracting. Okay, so let's go in here. Let's go and get started. Alrighty, here, draw, and we're going to have, okay, x squared, which is fine. Okay, that one is completely factored. Okay, we're happy with it. But let's look here. We've got x squared plus 4x plus 4. Notice carefully, I've got a perfect square, I've got a perfect square. So that's going to turn into x plus 2 and x plus 2. Minus, here, notice here, I can factor a 2 out, and that's going to leave me with x plus 4. All over, well, we got the same thing again. Luckily on this one, look, we've got the same denominator on both of them. So this makes it a little easier. So let's continue on. Put everything up under the same fraction bar there, and there we go. Now I've got x squared minus, well, always, I put everything, always, whenever you see a subtraction symbol, throw up a parenthesis symbol. Okay, here I'm going to go ahead and factor all that in together. I'm going to distribute that, and I end up having 2x plus 8. So notice here, I didn't even have to factor that out. I ended up having to put it back together. So sometimes you do that, sometimes you don't. Sometimes you don't know. But notice now I have a subtraction symbol there. I'm going to need to come in here and take this subtraction and distribute it inside there. So once I do that, I'm going to end up having x squared. I'm going to do this all in black. I'm going to have x squared minus 2x. Once I have a positive, I'm now going to have a minus 8 all over x plus 2 and x plus 2. Well, more than likely this top part's not factored right yet. So let's go and just double check here. We've got an 8, so we're going to use the AC method here, and I've got a negative 8. Well, what can I do to create a -2 and a -8? Well, let's come in here. How about we end up doing a 2 and a 4? 2 and a 4 is going to give me an 8. Okay, here. How about a -4 and a +2? Okay, -4 plus 2 will give me -2, then 2 times 4 is going to give me the 8. That works out perfectly. And what's nice is I've got a really nice a coefficient over here, so it's going to end up being x plus 2, x minus 4, all over x plus 2, and x plus 2. Well, looking at it carefully, we can go ahead and come in here and we can reduce out that. So our final answer is going to be x minus 4 all over x plus 2. That right there is our final answer. So that should be it. Let's look at some notes here. Yeah, some things I'm probably going to go over within class. So yeah, make sure to take a look at this, especially in your notes section. And then yeah, there's some extra homework solutions down below.